Hey guys, another video coming to you here for Chapter 2, Section 5 in our book. And our big essential question today is how can you use inequalities to describe intervals on the number line? So we're going to start getting into more complicated types of inequalities, ones that have a little bit more of a complicated number line than what we've been working on prior to this. So to get us started, in your notes, I'd recommend drawing a number line. Go ahead and draw a nice straight number line, and what we're going to do is we're going to graph something called a compound inequality. That'll be a key word today, compound inequality. So what does it mean to be a compound inequality? Well, that is when we actually have two inequalities that we're going to be putting on the same number line. So what I'm going to do is I'm going to put 0 in the middle. And I'm going to do my numbers in fives this time so I can get up to some bigger numbers. I'm going to go 5, 10, 15, 20. And in the opposite direction, I'll do the -5, -10, -15, -20. Please set yours up so it looks just like mine, so your notes match mine. And then here's what we're going to do. We are going to graph two inequalities on this number line. That's what's going to make it a compound problem. I'm going to be graphing x is greater than -10. And x is less than or equal to 15. Notice when I wrote the word and, I put it in red and I underlined it. I'm really trying to emphasize that and because that's a clue that this is a compound problem. X is greater than -10 and x is less than or equal to 15. Now later in class we're going to get into like situations like where in our world would there be a compound inequality. We'll connect this to that real life piece, like where does this happen? But for the moment, I just want you to see what it looks like on a number line. So let's start with x is greater than -10. I'm going to circle -10 on my number line. X is greater than means it's all the greater than values, so I'm going to be shading to the right. And I'm purposely doing this in blue because now I'm going to graph x is less than or equal to 15, and I'm going to switch colors. I'm going to make it red, so I have two different colors. So here's 15 on the number line. X is less than or equal to 15. Equal to means I better make a solid hole inside this inequality, so solid point. And then less than 15 is to the left. Now look what happens. I've got my red and blue arrows, but you notice when you graph this, you have this section that overlaps. The red and the blue are on top of each other. That's the solution to this problem. So what I'm going to do is I'm going to take my pencil or my highlighter or another colored pencil or marker, and I'm going to darken up that section in the middle where the overlap happens, and then I'm going to get rid of that blue arrow and that red arrow, and I don't need that box either. There's my solution. That's my inequality. That's my compound inequality. It's where do the two overlap each other. That dark shaded overlap is our solution. So there it is. It's between -10 and 15. That's a compound inequality. So you might need to keep like an eraser handy for some of these if you're working in pencil, or you might need to use like a dark marker to kind of shade and do the dark region that overlaps. You want your number line to be neat and clear and readable to whoever's looking at it. So you definitely don't want like arrows going in both directions and shading in the middle and it to get too messy. So you kind of have to keep that in mind. But that's a compound inequality. So let's try a problem now. Let's throw some solving into this. So we are going to solve for x. And our problem is this. Check this out. -4 is less than x minus 2 is less than 3. I see two inequalities, two less than signs. So in my mind, it's kind of flashing like this probably is a compound problem. So what I'm going to do to solve it is I'm going to do it kind of in steps. So step 1, separate this problem out. We need to break it into parts. We need -4 to be less than x minus 2 and x minus 2 to be less than 3. Look how I'm just copying the problem but copying it into two parts. I'm separating it. Then I go to solving. So step 2 is let's solve. Put a line down the middle and do what we already know how to do. We've practiced this a lot in class. We know how to solve for x. We're going to isolate x by itself. We're going to add that 2 over. Get -4 plus 2 is -2. We're going to add the 2 over on the other one. 3 plus 2 is 5. And we've got two solutions now. We have -2 is less than x and x is less than 5. Now for step 3, now that we have those solutions, now we're ready for graphing. So step 3 is the number line. It's time to make a graph. So I'm going to set up my number line down at the bottom, put 0 in the middle, and put all my numbers on there, 1, 2, 3, 4, 5, -1 to -5. And then I'm going to graph each piece of this kind of carefully. I'm going to start with the -2 first. Remember, if I'm going super fast, pause the video. I'm going to circle -2. X is the values that is greater than -2, so I'm going to be shading off to the right again. Again, I'm going to use 2 different colors to kind of show this, so blue and red. X is less than 5 means I'm going to circle 5, and less than would be all the less than values to the left. So again, we have a similar situation to the last problem we just talked about. We have a section of overlap, which I'm going to shade in dark, and then I'm going to use my eraser and I'm going to get rid of those extra arrows, and definitely the box isn't needed. There's my solution. This is a compound problem. I have 2 inequalities. They overlap on the number line. There it is. There's the solution. Okay, so that's a compound problem. Now it's your turn to try and see if you can do this. So here is your you try problem. 5 is less than x plus 4 is less than 10. This is the time to pause the video, solve, and graph this compound problem. We'll see if you got it right. Okay, I hope you're unpausing the video, and I hope you're ready to check your solution now. The steps were to separate it. So you separate it into 2 separate problems. 5 is less than x plus 4, and x plus 4 is less than 10. And then you get the x by itself by taking the 4 away. So you get the first solution is 1. You take the 4 away. 10 take away 4 is 6. Those are your 2 solutions. 1 is less than x, and x is less than 6. But now for the number line. Here is your number line. Notice I decided to kind of just ignore the negative numbers and focus on positives. So I went 0 to 8. And I'm going to circle 1 and 6. I started with the 6 this time first. X is less than 6 would be to the left. If I circle the 1, it looks like x is the bigger values going that direction. So I see where the overlap is. It's right in the middle between 1 and 6. So I'll get rid of those arrows. And there's my answer, between 1 and 6. And I hope that's what you also got when you did this. So take a look at your work, take a look at my work on the screen, see if we look similar, see if you made any mistakes anywhere. I always say this a lot, but the key thing here is your work needs to be organized and neat. You want people to be able to read and follow what you're doing. So it needs to look like you know what you're doing. So hopefully you're using a lot of neatness in your notes. Okay, this is not the only type of inequality I want to show you today, though. There's another one, so we're going to try another problem. Example 2. And we're going to change the variable. We're going to say solve for y. So here is our problem. It's no longer what I call an and problem. It's an or problem. 3y minus 5 is less than -8, or 2y minus 1 is greater than 5. It's greater than 5. So it definitely looks like one of these complicated inequalities. There's 2 inequalities going on here, but instead of the word and, I use the word or. And here's the difference. When we graph, you're going to see the difference. So let's go through our steps. Step 1, separate and solve. Well, it's already separated, so we just got to solve. I'm going to start with solving the left one by adding the 5 over. -8 plus 5, if I add that together, is a -3. So I have 3y is less than -3. And then I got to get rid of the 3 from the y, so I got to divide by 3 on both sides. And -3 divided by 3 is a -1. So y is less than -1. There's my first answer. Let's get the second answer. Let's add the 1 over to the other side. 5 plus 1 is 6. So I have 2y is greater than 6. I'm going to divide that 2 away from the y, divide by 2 on both sides. And 6 divided by 2 is 3. So y is greater than 3. So we have both of our solutions, and we're ready to put them on a number line now and see what it looks like. So step 3, number line. So here is my number line. I'm going to start on my number line by putting 0 and in the middle, and my usual numbers 1 to 5 and -1 to -5. And then I'm going to end up circling -1. Y is all the less than values, so everything less than -1 to the left. Then I'm going to circle 3, and y is all the greater than values, everything greater than 3. So going to the right. Notice something. There's no overlap happening here. The arrows did not go across each other. So there's no dark shaded region. We're not going to find any overlap at all. In fact, this is it. Our answer is that graph that you see down below. So you notice that an OR problem has two arrows pointing in the opposite direction and no overlap whatsoever. But an AND problem has overlap in a dark shaded region. And that's the big difference in these problems. So AND means they overlap, and OR means they go in opposite directions on the number line. So something you might want to put a big star in your notes or a little note to self, good thing to remember that OR points out and overlaps. Just an idea for you. Okay, so again, I want you to try because I want to know if you're getting this down. Here is your problem. I'm going to give you an OR problem this time. 2x plus 1 is less than or equal to negative 7, or 3 minus 2x is less than or equal to negative 1. Please pause the video, try it all by yourself, graph it on your number line, and we'll see if you got it right. Okay, I hope you're unpausing the video, and we are going to check your solution. We know that both these problems are already separated, so just put the line down the middle and isolate x. Take the 1 away from both sides. Negative 7 and negative 1 make negative 8. Then once you do that, divide by 2, and you get x is less than or equal to negative 4. And then same thing on the other one, get x all by itself. This one's a little trickier. You got to take the 3 away from both sides. You have negative 1 and negative 3 make negative 4. Then you have to divide by negative 2. And what did we learn earlier about dividing by a negative number? You have to flip the sign. So this was a tricky one. You had to remember to flip the sign. So the answer is x is greater than or equal to 2. And I hope you remember to do that flip of the symbol on that one. Okay, so now we put it on a number line. And on our number line, we're going to focus on negative 4 and 2. So here are my numbers. I'm going to circle both points. Oops, I somehow took the numbers off. Both of them have equal signs. They have solid holes there. And 2, x is greater than 2 is off to the right. And negative 4, it's less than, it's off to the left. And notice there's no overlap. So I know I feel pretty good I did this problem correctly because it was an OR problem and it's pointing in both opposite arrows are going in opposite directions. So that's a big clue that I did this correctly. But if you forgot to flip your symbol, that's not the case. You ended up with overlap, and that should have been a clue that something was wrong. So it's kind of something to look out for. All right, guys, so that's pretty much it for this video. Just remember the difference between an AND and an OR problem, and continue to work on your neatness of showing your steps and your neatness on your number lines. And again, we will practice this more in class. Bye, guys.